What is homeostasis? In biology, the term homeostasis is used a lot, and it can refer to many different biological processes. But at its core, homeostasis is actually a very simple concept. Homeostasis is the maintenance of a stable internal environment within an organism. Pretty simple, right? Just maintain the status quo and you'll be fine. That's a lot easier said than done. Maintaining a stable internal environment in a person means having to carefully regulate countless parameters which include body temperature, internal pH, internal concentrations of various ions, hydration, blood pressure, and glucose levels in the blood, just to name a few. So how do our bodies do all of this and keep track of everything at the same time? Well, for the most part, our bodies keep track of all these different conditions separately, and then make adjustments 1 or 2 parameters at a time, before something gets too far out of the normal range and starts affecting an important function. In this lesson, we'll take a look at one aspect of homeostasis by looking at how the human body maintains a stable body temperature. Humans, along with all other birds and mammals, are endotherms, which means that they actively maintain a stable body temperature by generating heat. Most people call endotherms warm-blooded animals. In contrast, most other animals, like reptiles, fish, and insects, are ectotherms, which are animals whose body temperature changes with their environment. People usually call ectotherms cold-blooded animals. You can remember the difference between endotherms and ectotherms if you remember that endo means inside and ecto means outside. So endotherms generate their own heat from within, and ectotherms get their heat from the outside. In general, ectotherms allow their body temperature to vary with the environment because it does not need to be maintained at a specific temperature for the animal to live. However, for most endotherms, body temperature must be maintained within a very narrow range at all times in order for the animal to live, with some exceptions for certain animals that lower their body temperature when they hibernate. Therefore, a stable body temperature of 98.6 degrees Fahrenheit, give or take only a few degrees, is one aspect of homeostasis in humans. The main advantage of having a stable body temperature is that it allows optimization of normal body functions, metabolism, and enzymes to a specific set temperature. This ensures that no matter what the environmental conditions, as long as the animal maintains temperature homeostasis, it will still be able to perform all normal body functions at or near optimal levels. However, there is a price to pay for always operating with full functionality, and that price is energy efficiency. Endotherms ensure a stable body temperature mainly by generating their own heat by burning calories. If they didn't have to maintain a high body temperature, they wouldn't burn as many calories, and therefore would be able to survive on less food or would be able to grow at a faster rate on the same amount of food. So now that we know why people maintain a stable body temperature, let's look at thermoregulation, or the regulation of internal body temperature. As stated before, our high metabolic rate is the major source of heat in our bodies. Most of the time, our body temperature exceeds the temperature of the environment, which means that we are continuously losing heat to the environment. The rate at which we lose heat is therefore a key determinant of body temperature, and many of the most effective methods of maintaining body temperature are based on either increasing or decreasing the rate of heat loss. Long ago, humans developed a unique method for controlling the rate of heat loss called clothing. You may laugh, but the most basic purpose of clothing is to provide insulation, which reduces heat loss. How much of a person's skin is covered by the clothing and how thick the clothing is determines how much insulation it provides and how much heat it conserves. Animals in the wild don't have clothing to increase their insulation. However, most endothermic animals do have a layer of insulation in the form of fur, feathers, or a thick layer of fat. Many animals experience changes in the thickness of these insulating layers to respond to seasonal changes in temperature. In addition, when mammals get cold, they immediately respond by raising their fur, which increases the thickness of their insulation. Even though humans generally don't have enough hair to serve as insulation, we still respond to cold by raising the hair on our bodies, which is why we get goosebumps when we are cold. This is a leftover response from our evolution.